Welcome back. These are the 9-3 intro notes. We have regular notes for 9-3, but this is to get us ready even for those notes. So if you can print this or copy it down, and let's get started on our 9-3 intro notes. So there's some questions that they're asking us here. The first question is, what is a zero? What is a zero? Well, a zero is also known as an x-intercept. If I go back to our pre-assessment, it was where our parabola crossed our x-axis. So these 2 points would be considered zeros. They're also considered x-intercepts, and they're also considered solutions. So we have lots of different vocabulary words that we can use to represent them. So what is a zero? Well, it's an x-intercept or a solution. It is the intersection point or points where a parabola intersects the x-axis. So what is a zero? A zero is an x-intercept or a solution. It is the intersection point or points where a parabola, that is P-A-R-A-B-O-L-A, intersects the x-axis. How many zeros can a quadratic have? Well, it actually depends. So let's draw a picture to help us see it. So here's the first one I think that most of you are pretty familiar with. This one has 2 zeros, 2 solutions, or 2 x-intercepts, because it crosses that x-axis twice. So there are 2 locations where that intersection occurs. But it's not always 2. Sometimes it's, bing, 1. That particular graph would have 1 zero, or 1 solution, or 1 x-intercept. Can you guys think of an example where a parabola would never cross the x-axis? What would that look like? Can you draw it before I draw it? What would that look like? How would I draw a parabola on this coordinate graph and never let it touch this axis? That one would never cross this x-axis. Neither would one that goes this way. So these would have no zeros. This one would have no solution, or no x-intercepts. So I just want you guys to know that there could be 2 answers, there could be 1 answer, there in fact could be no answer. Next, how do you find the zeros? Well, the only way that we know how to do it thus far is to graph. We would graph them like we did above and locate the given point or no point. So how do you find the zeros? At this point, we can say graph and identify the intersections. And we know sometimes it could be intersections because there could be 2, could be intersection because it could be 1, or it could be what I like to note as a flyby. It flies right by the x-intercept or x-axis and never touches it. But graphing, I mean, it's great and all, but is it the only way to find these special intersection points? No. In fact, it's, I think, the way that is, to me, one of the harder ways, because you have to have graph paper, you have to be very exact with your points. So one of the ways that we know how to do this is graphing. I'm not saying it's a bad technique, but it's definitely more tedious. Well, what's another technique? Well, we could use square roots. And either which way, you get the same exact answer. That's the cool part. Next, we could factor. Oh, yes, factoring. It's coming back to you. Yes, you still need to know how to factor. So factoring would be one. Complete the square. I still remember this lesson from my high school teacher at Danny Hills High School. His name was Mr. Deegan. He was a fabulous mathematics teacher. Just one of my favorites. Was also the surfing coach, so he was always covered in sand and wore shorts and flip-flops to class, and I loved it. It made me not take myself too seriously. I took math seriously, but because he was so calm and kind of cool, God, I just really loved math. What a rad dude. He's already retired, but I still remember this lesson from him, which blast of the past. I graduated 100 years ago. Okay, 1988. So we have one more technique. I know many of you have heard this, probably. The quadratic formula. Oh, yes. Oh, yes, it's a good one. So we technically have 5 different techniques to get the exact same answer, answers, or no answer. Again, answers, answer, or no answer. 5 different techniques. And trust me, each one of you will have your favorite. Do I have my favorite? Well, it depends on how it's set up to me. Sometimes it's really set up for a certain method over another. So I try to use the method by which it's set up for because I know that is probably the easiest algebraic approach. And last but not least, I'm trying to help you find a connection between the graphing and the square roots. So I'm going to stop the video now, and I'm just going to do that part next.